Here we have part 13 of the female reproductive system, page 1050, and we are continuing to look at these tables here, these sort of mapped onto each other graphs. Okay, and I would like you to be aware also that we have nomenclature to consider. So here are the pituitary hormones as they go through their cyclical change over 28 days. This is the LH, the FSH. We have that spike of LH, to a lesser degree FSH, as we have positive feedback from estrogen creating these spikes. Notice that we're going to be calling this first half of the ovarian cycle the follicular phase. So please remember this as the follicular phase. And then after ovulation, we have the second period of time that's referred to as the luteal phase. Again, we have these same tissues. They're all grown up, but they're now called the corpus luteum. And so the granulosa and thecal cells are situated in the corpus luteum. Here, the granulosa and thecal cells are situated in what's called a follicle. So follicular phase, luteal phase. Similarly, as we come down here, we're noticing that the endometrium has its phases. We have this initial menstrual phase right here, in which there is the loss of stratum functionalis, retention of the stratum basale, okay, functional basal. Okay, and then after 5 days or so, we have the proliferation period that's mostly guided by an increasing level of estrogen. So quick growing up, as it were, right here. Then we have the ovulation moment, and that moment creates this new phase here in which progesterone has picked up. We have a lot more differentiation, a continuation of proliferation, but now differentiation, and we have the formation of these glands. As you can see, finally there's the release of glandular output here to serve the hopefully implanting embryo at that point, blastocyst becoming embryo. So this is the secretory phase. So initially we have the proliferatory phase, quick growth. Then we have secretory phase, which is the output of glycoproteins and necessary things for the feeding and development of the blastocyst to implant and become an embryo. Okay, so there's that right there. You can take your time and look through these ideas here, and these pictures are available in your book. So we have that aspect here. They get a little bit into some other details of interest, the things that you might want to be interested in when it comes to sexually transmitted diseases at the time of sexual intercourse. And these would be items like gonorrhea, which you can look up, syphilis, the 3 stages of syphilis, chlamydia. These are all things of interest that you can look into individually. Okay, but I can bring you to the idea of different types of herpes, genital herpes, and so on, and warts. The next thing that I would like you to observe here is the determination of genetic gender. Sex is a very strange thing to be calling. Sex is is a physical act performed by consenting adults, presumably, and that it could happen between different genders or between similar genders. But the idea of gender itself, what are the gender-specific features that are conveyed by biological genetics or not? Sometimes there's not necessarily a cis-normative situation, and so there are people with multiple characteristics that span the normal expectations of gender. So some of this is determined by sex chromosomes. The Y chromosome has its SRY gene, as I mentioned to you in previous sections. Okay, there's a number of interesting details here where they indicate to us different types of options where there has to be at least an X chromosome, and if there's nothing else but one X chromosome, this is referred to as a Turner syndrome. These are all females because they have an X chromosome and no Y, in fact, no secondary sexual chromosome. Then we have individuals who are referred to as Klinefelters. I don't know if I can get this. There we go. And certain individuals have what's referred to as an XXY, two X's. I'm not seeing it here for some reason, but it's usually represented as a very tall female. An XXY is a tall individual who features characteristics that could be any range of both combinations of male and female. Individuals who present as Y and then no secondary, no X, cannot exist as a to-term individual. So that is problematic. They do talk about the descent of the gonads usually just before birth, so you can check into that sensibility. We went over this really interesting moment here in terms of determination of the individual based on their SRY gene if they are having a Y chromosome. If there's no Y chromosome, then of course we're going to be female. And in any case, we're going to be female if the Y chromosome gene does not work properly. Okay, and then finally there's this concept of menopause here, which I think is interesting. Historically, menopause is something that was described in very traditional literatures as being in, in terms of powers of 7, that sixth power of that sixth stage, as it were, in which we're going from 42 to 49. So these days we have the expectation of not having menopause until 50 or so. So at any rate, you can read about these things, but the decline of estrogen progesterone cycling is what menopause is about, and then the ceasing of menstruation. In terms of males, not so much, not so profound a situation is occurring, is that it's more gradual and so on. But I would refer you to this interesting little passage here, which I find fascinating, that in which they compare a 19-year-old. How does it go here? The difference in sperm motility with aging. Sperm of a young man, maybe a 19 or 20-year-old, will make it up the uterine tubes of the female in 20 to 15 minutes of swimming, whereas those sperm of the 75-year-old takes 2.5 days for the same trip. And when I'm in the classroom, I usually try to mimic little sperm with walkers, trying to get across the fabulous uterine pathway, and with every intention of desire and so on that would be associated with sperm and seeking an egg. But nevertheless, what is it that, that's to me very fascinating that the same tissues and the same cells that are produced over that same period of time in one individual, those individual cells are able to swim that particular race in 20 to 50 minutes, whereas the cells of an older gentleman are going to be taking 2.5 days. What are the differences? Are those mitochondrial differences? So the idea of senescence aging and that sort of thing, and tissue and cellular decline. Very interesting stuff, so worth looking into.